Okay, so in this video, I want to make a brief introduction into what are pneumatic circuits. Basically, I want to explain only the symbology, and then I will make a video related into how you can simulate these pneumatic circuits. So I think that it is important that in order to generate a pneumatic circuit, we need to first understand what is the symbology of the basic unit of pneumatic circuits that are the directional control valves. Okay, so the symbology of a directional control valve is as follows. For instance, here in the left, we have two boxes. These boxes represent the number of positions of the directional control valve. So for example, we have here one box and here we have a second box. So these two boxes implies that this directional control valve has two positions. Okay, so in this position, the airflow will move in a certain way. And in the second position, the airflow will also move in a different way. Okay. And also, we denote the number of positions by the number 2 because we have two positions or two boxes in this directional control valve symbol. Also here, you can see that we have different input ports, okay? The ports in the directional control valve basically means that the ways in which the airflow or the input ports in which the airflow can enter and exit the directional control valve. So for example, in the right, you can see that we have two boxes. That means that this valve has two positions, but also you can see that we have port A and B and port B and T. And the number of ports is also repeated in the second position. Okay, but you can notice that for the first position, the airflow is moving from port A to port T. And in the other port, the air is moving from port B to port B, okay? And this is basically indicated by the arrows or the direction of the arrows in this position. But when I switch the valve to the second position, you can notice that now the airflow is moving in a different way. Here, the air is moving from port B to A and also from port B to D. Okay, so this is basically the meaning of these arrows, no? They show how the airflow is moving between ports, okay? And also you can see that we have four ports for each of the positions, okay? So we can say that this is a four port or four ways with two positions valve. And this is often denoted by with a four, that is the number of ports, a diagonal, and then we have two, that is basically the meaning or refers to the number of positions in the directional control valve. Okay, so remember, in order to describe a directional control valve, we use first a number that indicates the number of ports. Here we have four ports, so we use a 4. Then we have a diagonal, and then we have a 2. And this 2 refers to the number of positions in the directional control valve. Okay? And remember that the number of positions is basically determined by the number of boxes in the symbol of the directional control valve. So, well, let's continue. So this is another example. So for example, here you can see that we have a two-position valve. So we can place the diagonal and then the 2 in order to refer to the number of positions. But also you can see that we have only two ports, okay, A and B. And you can see that this symbol, in particular for the first position, refers that there is no airflow. Okay, the airflow cannot move in this position because we have this symbol. That basically means that the exit or the input of air in this position is blocked, okay? But for the second position, you can see that the airflow is moving from port B to A. And also we can see that we only have two ports or two ways. So we can indicate this by a 2, okay? So you can notice that in this first position, there will be no airflow. But in this position, there will be certain airflow and this will be from port B to A, okay? So I think that's it for this slide. Let's continue. So we have here another valve example. For example, in this case, you can see that we again have a two-position valve. So we can denote that by the number 2 after the diagonal. And also you can see that we have three ports because here we have three letters, A, T, and P. Okay? But you can notice that if you look closely to this behavior, you can see that for the first position in the left, we have here port A, we have port P, and we have port T. Okay? And based on this information, we can see that we have three ports or three ways. So we can denote that by the number 3 before the diagonal. So we can say that this is a three-port or three-way and two positions valve. Okay? But in the first position, the airflow is moving from port P to A. Okay? In port T, there is no airflow because we have the symbol. But for the second position now, port P does not have an airflow. And then the air is moving from port A to port T. Okay? And this is denoted by the direction of the arrow. Okay? Right here. So as you can see, determining the number of ports and the number of positions in a directional control valve is relatively easy. You only need to follow the diagram and you will notice that identifying the number of ports, the number of positions, and also how the airflow is moving is relatively simple. Another important aspect is, well, also these symbols tell us about how the directional control valve will switch between positions. And we can switch the positions of the directional control valve by different mechanisms. For instance, you can use an electrical device like the solenoid. This is the symbol of a solenoid or a relay. We can also use a button, and this is the symbol of a button, but also you can use a spring, okay? So you can switch to position 1 in this directional control valve by using a spring. But if you want to switch into the second position, you can use a relay or solenoid that is activated electrically. So for instance, here the button and the spring are switched to position 1 in a mechanical way, but in order to switch to position 2, you need to use an electrical component that is the relay. So basically, we can denote how we are switching between positions by using the symbols. And these symbols are also, well, are always placed at the sides of the directional control valve, no, in these regions. Okay, well, I think that's it for this part. Let's continue. So another important symbol is the symbol for a cylinder or a piston. Here we have the cylinder that is basically the cabin in which the piston is located, and this is the piston. We mainly have two different types of cylinders or pistons that we can use. We have a single acting cylinder. Basically, this means that, for instance, in the case of this symbol, you can see that we have a spring, no? So the spring is used to return the piston to its retracted position. But if you want to extend the piston, you need to push air or add air pressure in this side in order to push the piston into the opposite direction and in this way extend the piston. Okay, but this is called a single acting cylinder because you only need to fill air in this cabin because the piston can be retracted automatically by using a mechanical system that is the spring. But the double-acted cylinder requires that in order to extend or retract the piston, you need to push air in this region, no? Add pressure air in this region in order to extend the piston. But if you want to retract the piston, you need to add air pressure in order to retract the piston in this region. Okay, so you need air pressure in both sizes or in both sides in order to extend or retract the piston into its two different positions, no? The extended position and also the retracted position. Okay, so this is the way in which you can differentiate the difference between a single acting and double acted cylinder. The single acted cylinder only requires air in this region, no? But the double acted cylinder requires air pressure in both sides, okay, in order to retract or extend the piston, okay? So this is the way in which you can identify a piston or a cylinder in a pneumatic circuit. And well, this is like a diagram, no? So for the following video, I will explain how you can simulate this pneumatic circuit in fluid sim. But let's analyze what is happening first in this pneumatic diagram. Here you can see that we have a button. Okay, so this button basically means that in order to switch to this position, you need to push this button. Okay, and in here you can see that also we have a spring. So this means that in order to switch for the second position, you need a spring. No, the spring will retract or move the valve into this particular position. Also, you can observe that we have a two-position valve. Okay, remember that we use a diagonal in order to denote the number of ports and also the number of positions of a directional control valve. So here you can see that we have two positions. So we have here the diagonal and we place a 2. And also you can see that we have one port right here. We have another port right here and also another port in this part. Okay. So you can see that in this case in port C, there is no airflow due to this symbol. And also you can see that the air in the first position is moving from port A to port B. But in the second position, we have again port B, and also we have here port C and port A. So you can observe here that here there is no airflow in port A in the second position, but the different behavior is that now the air is moving from port B to port C. Okay, in fact, this is the symbol of an air exit. So this means that the air is exiting is an air exit right here when the piston is retracting. Okay, because the air moves from this region through this connection or via this tube, and then the air is pushed into this region and is exiting to the environment. Okay, but in the other position or the first position, you can see that, well, this is the symbol of an air source. So the air will move from port A to B through this connection, and then we'll go to the cabin of the piston in order to extend the piston. Okay. So this is essentially an overview. I think that it is very complicated to grasp all the things together in the first view. So I think that I will make in the following video a simulation in order for you to understand how you can analyze and how you can understand the behavior of these pneumatic circuits. So just take only to finish this part, just remember that this directional control valve has 3 ports. So we can denote that by these two numbers. The 3 refers to the number of ports. We have a diagonal and then we place a 2 that basically refers to the number of positions. Okay. So that will be all from my part for this video. I hope you like it. In the following video, I will explain a little bit more in detail in how you can simulate this type of pneumatic circuits. See you next time.